All right, this video is going to go over how to get angles when they give you an exact value. So the first thing that I would draw if I was doing this is I would draw all students take calculus. All right, now here's what's about to happen. You're about to have multiple answers because if you think about it, like if you had an angle right here, if you did another full loop and got another angle at that location, both of those would work. They're coterminal. So here's what I'm getting at. You're about to have multiple answers, and you have to account for when those answers would repeat. So do a imagination here. Imagine I got one answer here and one answer here. The red would be whatever angle, and then the next time it would repeat is after a full loop. So angle plus 2 pi. The blue would be this angle. And then the next time it would repeat would be after a full loop. So after 2 pi. There's also going to be times where you have like one angle here and one angle here. And so you'll be like, all right, well, green would be the angle plus 2 pi again, right? Because that's when it would repeat again. But no, if you think about it, it'll repeat when it gets to the orange one here. So just plus pi. And then it would repeat again if you did another pi. I hope that kind of makes sense. You're going to be seeing a lot of this. Just bear with me here. All right. Sine theta equals 1/2. Let's just see some examples. Where sine is 1/2 is basically what it's asking you. That means you're going to need a coordinate that's something along the lines of √3/2, 1/2. So that reference angle is pi over 6. And for sine to be positive 1/2, that would have to be in quadrants 1 or 2. So the angles that are over 6 in quadrants 1 and 2 would be pi over 6, and 5 pi over 6 is the one in quadrant 2. So the way you answer this, look at this example. We have an angle that's in quadrant 1 and an angle that's in quadrant 2. So the way you would answer this is you would say, well, it's pi over 6 plus a full loop, so plus 2 pi. But there could be any amount of loops. You could do like 5 loops and end up at that same location. So you have to put a little in here saying number of loops. So plus 2 pi n is the way it looks. Then you have to account for like the blue angle in this example. That was the red one. Now we got to account for the blue one, which is 5 pi over 6 plus 2 pi n. I hope that made sense. Tan theta equals -1. For it to be 1 or -1, it's got to use √2/2, √2/2. That's the only place where the y and the x are the same. So that reference angle is pi over 4. For tan to be negative, that only happens in quadrants 2 and 4. Quadrant 2, quadrant 4. Now, the angle that's over 4 in quadrant 2 is 3 pi over 4. The angle that's over 4 that's in quadrant 4 would be 7 pi over 4. So the way you answer this is kind of like this example where, like here, I'll draw it off to the side. We've got this angle that's in quadrant 2, and then we've got this angle that's in quadrant 4. You don't have to claim both of these plus 2 pi n plus full rotation. You can just claim the blue plus a half rotation plus a pi. It's kind of like this, what I was trying to explain before we started. So my answer here would be 3 pi over 4 plus pi n. Because as soon as you add pi n, you end up at the red arrow there, which covers you for the quadrant 4 answer. All right, the next one. Cosine is root 3 over 2. This only happens when the coordinate is root 3 over 2, comma 1/2. That's pi over 6. Cosine's positive, right? They're telling me positive root 3 over 2. Well, that only happens in quadrants 1 and 2. Sorry, 1 and 4. So the angle in quadrant 1 is just pi over 6. The angle over 6 in quadrant 4 is 11 pi over 6. So this is kind of like the red and blue scenario here, where we've got not opposite quadrants. So basically, we're going to have pi over 6 plus a full rotation, 2 pi n. Then we'll have 11 pi over 6 plus a full rotation, 2 pi n. And if you drew it out, it would look like this. We've got one angle here in quadrant 1. We've got one angle here in quadrant 4. You can't just say blue plus pi n because that puts you in quadrant 3, which is not a good answer. So that's why you say plus 2 pi n to get back to the blue. And then you have to claim red as well, plus 2 pi n to get back to that red spot. I hope this is making sense. All right, tan theta equals negative root 3. Whenever I see this, I put over 1. And I'll also put, whenever I see tan, if my computer cooperates, okay, we're jumping around. Whenever I see tan, I also write y over x. It helps me because now I know that the numerator of my x has to be a 1. So it's got to be 1/2. And then the numerator of my y has to be a root 3. So it's got to be root 3 over 2. This coordinate's at pi over 3. So now I go and think to myself, okay, where's tan negative? Tan's negative in quadrants 2 and 4. So the angles that are over 3 in quadrant 2, it's going to be 2 pi over 3. And in quadrant 4, that's 5 pi over 3. So if you thought about this one, let me erase these old ones. If you thought about this one, we've got something in quadrant 2. We've got something in quadrant 4. So you can just say it's blue plus pi n because that would take you to the red. So my answer here would be 2 pi over 3 plus pi n. All right, the next one. Tan is negative 1 over root 3. That's y over x. That means it's going to be like root 3 over 2, 1/2. This happens at pi over 6. Where tan is negative, again, is in quadrant 2 and quadrant 4. The angles that are over 6 in those locations would be 5 pi over 6 and 11 pi over 6. So this is kind of the same scenario that we just drew here. You got 1 in quadrant 2, 1 in quadrant 4. So you can just put the quadrant 2 answer, 5 pi over 6 plus pi n, because that'll take you to the red. All right, let's jump down. I don't feel like doing all of these. Let's look at like some of the bottom ones. They're quadrantals. So like where's tan 0? The only place that's going to happen, remember, put it 0 over 1 and write y over x. That means you're at a coordinate of 1, 0. So that would be here. But it could also be negative 1, 0 here. So in terms of reference angle, you don't have one. You're just on the positive or negative x-axis. So your angles here are either 0 pi, I guess, or pi, because that would be these two locations. So this is kind of like this example right here, or sorry, this example right here where they're oppo from each other. So to get from like the red dot to the blue dot you would only have to add pi. So my answer here would be 0 pi plus pi n. Let's look at another one. Cosine theta being -1. Well, that's going to be at a coordinate where an x value is -1. That's -1, 0. So there's no reference angle. That's on the negative x-axis only. It's right here. So it's going to take a full rotation to get back to that spot. So it's at pi, but my answer is going to be pi plus a full rotation, 2 pi n, to get back to that location. What about if it was sine theta equals 1? That means I have a y value of 1, 0, 1. This happens at pi over 2. It's on the positive y-axis. Happens at pi over 2. And that's the only location, so it's going to take a full rotation to get back to that answer. So that's going to be pi over 2 plus 2 pi n, like this. Okay, so that's how you do those quadrantals. I don't feel like doing any more of those. Now I just added 3 problems over here. Let's look at if it was like one of the opposites. So like if it was cosecant -2, the first thing I would do is I would make it -2 over 1. And then I would say cosecant is sine flipped. So this is really like sine theta equals, flip it, -1/2. Because once I see that, I know I have to have this coordinate, √3 over 2, comma 1/2, as my reference angle. Well, that's pi over 6. But it's negative. So that means it's got to be in quadrant 3 or quadrant 4. Well, the location of the angle that's over 6 in quadrant 3 is 7 pi over 6. And then in quadrant 4, that's 11 pi over 6. So my answer here for this one, if I was in these quadrants, 3 and 4, here and here, think about the blue. It would take a full rotation to get back to that. Think about the red. It would take a full rotation to get back to that. So both of these answers are going to be plus 2 pi n. So my answer here would be like 7 pi over 6 plus 2 pi n. And 11 pi over 6 plus 2 pi n. Let's look at another. Secant of -1. I'd make it -1 over 1. I'd call it cosine theta, and then I'd flip it. So it's still -1. So where that's going to happen is right here, an x value of -1. So that's at pi, and it won't repeat again until you do a full loop. You have to do a full loop to get back to that location. So my answer here would be pi plus 2 pi n. All right, and then this last one, cotan theta equals -√3. First thing I would do is I'd put it over 1. Then I'd call it tan. And I'd flip it. So -1 over √3. I'd also write y over x whenever I did tan. So now I'm looking for this coordinate with an x numerator of √3 and a y numerator of 1. So my reference angle here is pi over 6. But now I have to think about cotan is negative in quadrants 2 and 4. So the over 6 angle that's in quadrant 2 is 5 pi over 6. And in quadrant 4, it's 11 pi over 6. Well, if you think about this one, if we have an angle in quadrant 2 and an angle in quadrant 4, you could just say I have blue plus half of a rotation, because then it would be at red and it covers the red. So my answer here would be 5 pi over 6, just plus pi n. So that's how you do angles when they're giving you the exact value. Hope this video helped.